We are going to be talking about limiting reagents, and you're going to hear me use the word reagent and reactant interchangeably. A limiting reagent is one of the reactants in an equation or in a reaction is going to limit that reaction. As an example, say that I mix 10 milliliters of one solution and with 20 milliliters of another solution, they react, they form the product. Some of the reactant isn't going to be able to react because it's used up. So when you use up one of the reactants, whatever's left over of the other reactant is said to be in excess. And whatever is used up first is limiting the reaction and determines how much of the product you can actually make. So I'm going to show you how to calculate limiting reagents using stoichiometry, and I'm going to give you two separate examples that you can use. The first example is a double replacement reaction, so I have silver nitrate is added to sodium chloride to produce a solid precipitate of silver chloride and sodium nitrate. So the question is 5 grams of each reactant is used in the above double replacement reaction. How much precipitate, which is silver chloride, can be produced from the limiting reactant? So we need to figure out which one of these reactants is limiting the reaction and which will be in excess, meaning unreacted solution left over at the end of the equation, or end of the reaction, I'm sorry. Okay, so the first step is to figure out what you know and what you don't know. You have 5 grams of each reactant. So I have 5 grams of silver nitrate, and I have 5 grams of sodium chloride. What am I looking for? How much precipitate can be produced? So I'm looking for the mass of silver chloride because this is my precipitate right here. Okay, so this gives me a place to start. This is a little different because we have 2 knowns and we've never had that before. If you have 2 knowns, you have 2 separate equations. So we're going to deal with silver nitrate first. So I'm going to put my known over 1, put it over here, and I'm going to go to my unknown. So my first equation is going to be with my first reactant and the unknown, and my second equation will be the second reactant and the unknown. So 2 separate equations going to the same place. So you start with your known over 1, and this is using stoichiometry and the balanced chemical equation. These are all 1, 1, 1, 1. So this equation's already balanced. I'm going to figure out the mass of silver chloride produced. Okay? So the only place I can go out of grams is into the mole. So I know that 1 mole equals the molar mass of silver nitrate, and the molar mass of silver nitrate is 169.88. So grams of silver nitrate cancel out. Once I'm in moles of silver nitrate, I can go through the mole ratio, and because this equation's already balanced, it's 1 mole of silver nitrate produced 1 mole of silver chloride. So I know that 1 mole of silver nitrate, moles of silver nitrate goes in the denominator to cancel out with this numerator, and it produced 1 mole of silver chloride. So I went from here to here. Now that I'm in moles of silver chloride, I can go to grams of silver chloride, so I know that 1 mole of silver chloride is equivalent to 143.32 grams. That's the molar mass of silver and chlorine, AgCl. So I've reached the units of my unknown, so I stop. So then multiply your numerators, divide by your denominator. So I'm going to take 5 times 143.32 equals, and then divide by the denominators, 169.88. And I get 4.22 grams of silver chloride. So if I use 5 grams of sodium nitrate, I should expect to get 4.22 grams of silver chloride. Okay, well, that's only half the problem. I need to figure out how much silver chloride 5 grams of sodium chloride is going to produce. So I do the exact same thing, but I start with a different known. So I am going to start with 5 grams of sodium chloride, set that up into a T-chart, and the molar mass of sodium chloride, which is sodium, and 22.99 plus chlorine, which is 35.45, is equal to 58.44 grams of sodium chloride for every 1 mole of sodium chloride. So grams cancels out with grams. And now I'm going to use the mole ratio. Well, it's still a 1-to-1. 1 mole of sodium chloride produces 1 mole of silver chloride. 1 mole of sodium chloride in the denominator to cancel those units for every 1 mole of silver chloride. And then, well, now that I'm in moles of silver chloride, I know that 1 mole of silver chloride is equivalent to 143.32 grams of silver chloride. So this last step right here is exactly the same because you're going to the same place. You have the same unknown. So once you reach the units that you're looking for, you stop and calculate. So my numerators, I take 5 times 143.32. That's going to give me the exact same numerator value that the first equation did. However, I'm dividing by a different value. So I would take that and divide it by 58.44. Get a much larger number. Okay. Now that we have these two values, this is where the limiting reagent concept really comes in. 5 grams of silver nitrate will only produce 4.22 grams of silver chloride. However, 5 grams of sodium chloride can produce 12.26 grams of silver chloride. 4.22 is clearly smaller than 12.26. Therefore, I would say that silver nitrate limits the reaction. So silver nitrate only produced 4.22 grams of silver chloride. Therefore, it limits the reaction. So it is the limiting reagent, which means that if I put 5 grams of each of these into solution, I would only get 4.22 grams of silver chloride out, and there would be excess unreacted sodium chloride left in the solution. So I have my limiting, and I have what I have in excess. So if this reaction were to take place, it will only produce 4.22 grams of silver chloride. Now, if I wanted more silver chloride, I would have to increase the amount of silver nitrate I put in, because that's what's limiting the reaction.